You don't have to take notes on this. Just look with me up here. We can't forget everything we've learned this year, and this is one thing that it's a no-brainer. We should never miss this type of problem. So it says multiply the polynomial and put into standard form. So it sounds like a dumb question at this point for you guys because you're getting so smart. But can we just square negative 3x and square negative 1? No, that would be breaking the forbidden rule. So we would rewrite this one as negative 3x minus 1 times negative 3x minus 1. Now, once again, even though this has gone really easy for us, I still see a lot of you missing them. So let's make sure you're not just like, I already get how to do this, so I'm not going to really pay close attention, because you need to. So negative 3x times negative 3x is what? Good, 9x squared. Now, once again, a lot of people forget to put the squared on that first piece there. And then negative 3x times by negative 1.
3x.
Positive 3x. Very good. I've distributed negative 3x to both terms, so now I'm going to distribute negative 1. So negative 1 times negative 3x. Positive 3x. And then negative 1 times negative 1. Positive 1, so plus 1. Then from there, because we're putting it in standard form and we're combining like terms, so it's in the simplest form, 9x squared plus what?
6x.
Good. I like that you said 6, because we're just combining like terms. Another common mistake is multiplication, but we're just 3 apples plus 3 apples is 6 apples. So 3x plus 3x is 6x plus 1. So anyways, that was a good one to review, hopefully. Okay, let's get on to what we're learning today. So today is 5-1. We're starting a new unit today. We're going to be dealing with rational exponents and some more radicals. So rational exponents. So we're going to be finding the nth root first of all, which the nth root just means we're going to be able to find any root. We just practiced this finding square roots, just barely, but we're now going to practice this finding any type of root. So nth root just means whatever I want, I should be able to find. So if I want to put in a 5, I should be able to find the 5th root, 4th root, 3rd root, whatever. So the rule is the exact same as a square root. What we do is we break it down into its prime factors. So whatever's under the house, we break it down into its prime factors. Now remember, prime means nothing multiplies to be it besides 1 in itself, or it's not divisible by anything other than 1 in itself. And then our second step is to pull out groups of size n. So we knew if it was a square root, we pulled out groups of size 2. If it's a cube root, we pull out groups of size 3, 4th roots, groups of 4, and so on. Does that kind of make sense? It'll make more sense once we start practicing it. But it should make some sense to you. Does it? We're all good. Okay. All right, so let's go on. So let's just do some examples. So it's straightforward. Very same thing as a square root. We just start off by breaking it down. So I'm going to break down the cube root of 27 into its prime factors. So what multiplies to be 27? 9 times 3. And then we break down 9 further. 9 breaks down into 3 times 3. So then because it's a cube root, we have to pull out groups of 3. So if there's 3, it can leave the house. Otherwise, it's got to stay underneath. So there's 3 3s right there that can come out. Is the 9 still there? No, right? That would be double dipping. 9's not there. We rewrote 9 as 3 times 3. So we pull out a 3. Was there anything left under the radical? Nope. So our answer is 3. Is everybody good with that? All right. So the square root of 81. We already know how to break this one down. 9 times 9. 9 breaks down into 3 times 3. 9 breaks down into 3 times 3. Pulling out roots of 2, since it's a square root, we know it goes without being said there's a 2 there. So we pull out a 3 for those 2 3s. We pull out a 3 for those 2 3s. So 3 times 3, and there was nothing left underneath. 9 would be our answer. Questions on that? That's not new to us. Unless... Yeah, so good point. Justin is making some connections here. Could we have just said, oh, 9 times 9, is there 2 of them we can pull out? Yeah? So we pull out a 9 for those 2 9s, anything left underneath? Nope, so absolutely. That's a good strategy to use. The only reason I continue to break down, and at a secondary math 3 level I would have stopped. At secondary 2, people start to forget that if something's left underneath, they keep breaking it down. Does that make sense? Okay, awesome. Good point, Justin. I'm glad you brought that up. Okay, let's do the 4th root of 64. What are some factors of 64? 8 8 times 8, and then 8 breaks down into 4 times 8 breaks down into 2 times 4. 4 breaks down into 2 times 2, and 4 breaks down into 2 times 2. Now let's not double dip. I'm going to cross out things because it's getting pretty messy in here. 8's not there. Okay, so now I know what's in there, what I can circle to pull out. We're pulling up groups of what size? The 4th root. So if there's 4, they can leave the house. There's 1, 2, 3, 4 2's right there, so they can leave the house. But what about these 2 2's? They're going to stay underneath the 4th root. So we still have the 4th root of 2 times 2, which is 4. Everybody okay with that? So really at this point, we should be able to break down any type of radical I throw at you, because now you know how to do it. Now let's all get out our graphing calculators, because I'm going to show you how you can type it in, even if it's not a square root. So you can type in cube root, you can type in the 4th root even. So let's go ahead and learn that. So everybody, graphing calculators, follow me through these steps, because it's a little bit interesting here. Okay. So if you want to do the square root, we obviously know that you do second square root. So let's do the square root of 81. Because remember, I always check on my calculator first if it's a whole number root. And if it's a decimal, then I go back and break it down by hand. So I did the square root of 81, and I hit, my recording needs to go away. Okay, there. I hit enter, and we got 9. Is that what we got when we did the square root of 81? Okay, awesome. So now let's type into our calculator the cube root of 27. We better get 3. So cube root of 27. You can't type in the square root. It's different than the cube root. So this is how you type it in. Everybody, you hit the math key. Now, is everybody there? Scroll down. Does everybody see how number 4 says a cube root? So you hit enter, the cube root of 27. And then I hit enter, and I get 3. So if you look at what we got, once again, we did get a 3. Let's try this one, because once again, if it's a decimal though, and it's going to be, we would break it down by hand, because this is more simplified than the decimal answer. But let's just type it in. So this is how you type in something else. Everybody ready to learn? You have to do this one a little bit differently. So if it's not a cube root, you have to manually type it in like this. So you hit I'm going to do the 4th root. So I have to type a 4 first, and then I have to go to the math key. So type a 4 first, and I go math. And then if you look down at number 5, notice how it has an xth root. Well, you just told it you want it to be the 4th root. So you're going to hit on the xth root, because you told it you wanted it to be 4. So see how it typed it in as the 4th root? Now your TI-83, the older ones, will just, it'll look a little bit different. So it'll work the same way though. You'll do the same steps. It's not going to change anything, but it's recognizing your calculator's logarithm is set up so that it knows that that's the 4th root. Okay? So the 4th root of 64, which we're going to get a decimal, but let's just type it in for fun. So you hit enter, and we get 2.828. Which, once again, if we got that, we would go back and break it down by hand, because this is more simplified. Now I'm going to type that in to show you that it's the exact same thing, but this is the more simplified answer. So 2 4th roots of 4. If you type that into your calculator, 2, and then you have to hit parentheses, and then 4th roots, so you hit the 4, and then down to the math key, and then down to root. So the 4th root of 4. 2 times the 4th root of, and then I need to scroll out this more advanced calculator here. Okay. 2 times the 4th root of 4, and look, we get the same decimal. But this is considered the more simplified answer. That's why we break it down by hand. Does everybody get what I'm doing there? Okay, awesome. All right, guys, so now you should be good to do problems 1 through 9. I would start off by just trying it on your calculator first. Why break it down by hand if it comes out an even root? So those should be pretty quick. Most of those come out as even roots. If it comes out as a decimal, break it down by hand. 1 through 9, ready, set, go. Goes hand in hand. Okay, this is a huge thing that we're learning today. This is something you're going to see in secondary math 2, the rest of the year, secondary math 3, and it's a huge deal here. So we have seen properties of exponents with rational exponents. And now we're going to build our knowledge on rational exponents. So radicals is what we've been dealing with the past, just a second ago, and then the past few lessons. Radicals and rational exponents go hand in hand. In fact, they're equal. So recall that rational means, first of all, so that you're not like, what does she mean by rational? Just a reminder, rational means that it is written as a fraction. So an example of a rational would be like 2/3, because rational means it's written as a fraction. So rational exponent, something raised to a power of a rational exponent. So notice how we have a fractional exponent that's equal to a radical. Radicals and rationals are equal. This is a different form than this, but they're equal. So this is apples and this is applesauce. They're equal, but they're in different forms. So today we're going to have to be able to switch back and forth between radical form and rational form. But does everybody understand that they are equal? They're the exact same thing, but different forms. So once again, the apples and applesauce thing. Okay? All right, so we're going to be able to switch back and forth after today's lesson. So here's a little trick to help you remember. Because notice we have a cube root of x to the second power, right? Right here. And notice we have a 3 on bottom and a 2 on top. So I'm going to teach you a little trick to help you remember this. So think of a picture of a flower. So you'll remember this forever, even in secondary 3, because you'll deal with rational exponents quite significantly. All right, so think of a picture of a flower, you guys. A flower grows, and under here on bottom, our roots grow, right? And then on top, we have our sun, which shines down from the top, is our power. So our power comes from the sun, and our roots come from the bottom, just like a flower. So notice, rational exponents will be written with a root on bottom and the power on top. So just like a flower has roots on bottom and the power comes from the top, the roots are on bottom and the power is on top. So that's an easy way. That picture will really hopefully help you remember quickly how to rewrite these things. Instead of just memorizing it, think of your picture of your flower with your roots on bottom, your power on top. Does everybody got that down? You get the picture. Okay. So, let's rewrite these are in radical form. We're going to rewrite them with rational exponents. So once again, with rational exponents. So if you were to read this out loud, this is the cube root of x to the second power, right? Everybody? So we have base x, so I'm going to write x. Then I know I'm going to have a fractional exponent, so I put my line in. Our power's on top, so our 2 is going to be on top, and our roots are on bottom. So since it's a cube root, 3 goes on bottom. And we're done. Does that make sense? How to do that? Easy way to remember. All right, so let's look at this next one. We have the 5th root of x to the 4th power. So you have base x, and then we have a fractional exponent, and we put our power on top, so 4 goes on top, and the root goes on bottom. 4/5 power. Is everybody comfortable with that? So hopefully that picture of the power with the roots, power on top, roots on bottom really helps you. A couple more. So we have blank root, but what is it? We know it's a square root of x to the what power? 1. Very good. Way to see that. So if I need to, I could write in a 1 and a 2 if it helps me. So we know that we're rewriting it with rational exponents. Fractional exponents, roots go on bottom. So 2 goes on bottom, power goes on top. 1 goes on top. Right? All right. Questions on that one? Okay, we're almost there. Guys, stay with me here. So we have the 4th root of x to the 2nd power. So we have x to the 2 over 4, right? Roots are on bottom. Now does 2 over 4 simplify? X to the 1/2 power. So those are equal. Very good. All right, and last one here. Well, let's see here. We're almost getting there. The cube root of a to the what power? 1. So we have a to the 1 over 3. Roots are on bottom, so 3 goes on bottom. Very good. Is everybody comfortable with those? We were starting out pretty basic there. Okay. So now I want you to understand something. Recall, we have learned kind of the hard way with a few of us in this class that parentheses can make a huge difference. It's a night and day difference in a problem. And in math, that's just true. Little details count. So parentheses make a huge difference. So I want you to just look with me at these two things. 2x in parentheses squared versus 2x squared. This is what gets students at this level every time. So looking at 2x in parentheses squared, I'm going to ask you a question. Is 2 and x both squared? Yeah, right? That's what that parentheses is saying. Anything inside these parentheses is raised to the second power. So wouldn't that be 2 squared, right? You raise both power to a power and you multiply the powers. 1 times 2 is 2. And then x to the first, 1 times 2 is... So 2 squared, x squared. You see how I squared both of them? Which makes sense. That's what the parentheses are specifying. Okay, what is 2 squared? So we have 4x squared. So this would be our answer for the one in parentheses. Now look at this one over here. This is the tricky one. Is 2 and x both raised to the second power? In fact, it's not. This is just simply 2 times x to the second power. At 2 is not raised to the second power. It would be in parentheses if it was. So our answer for this one is just 2x squared. Do you see how big of a difference these two answers are? Yeah. Okay, so this is where the common errors come in. So you got to really look at your parentheses and be careful. So that brings me to my next example. We're going to rewrite this with rational exponents. So I'm going to ask you a question. Is there parentheses? So are they both raised to the second power? Yes, and are they both under the same root? Yep. So if we want to write this with rational exponents, we've got to keep those parentheses. 2x to the 2 goes on top, power's on top, right? And roots are on bottom, so 3 goes on bottom. This is it in rational exponent form. Is everybody okay with that? We're all doing okay? Okay. Well, then let's look at this one. Are they both, is 5 and x both raised to the third power? And they're both under the fifth root? Okay. So we have 5 and x, and they're both raised to the third power, and they both are under the same root. So 3/5 power. Is everybody comfortable so far? Because they're going to get a little bit more difficult. Do you have questions on that? No? So let's look at these two. This is probably the hardest ones for students to get. So let's look at this one. I'm going to ask you a question. Are they both raised? So pay very close attention and ask questions if I'm not clear here. Are 5 and x raised to the third power? No. So they each have their own power, right? Isn't 5 raised to the first power? Yeah. Okay, awesome. But they are both under the same root, right? Okay. So we are going to say, okay, 5 to the first power, right? X to the third power. And aren't they both? So we're going to put them under parentheses, under the same root. So 1 over 3. The root's got to go on bottom, right? Root's got to go on bottom. So if I put it 3 up here, would it have been a cube root? No. So do you understand why I put the 3 on bottom? Because it's a cube root. Oh, fifth root. 3. So it's a fifth root, so roots go on bottom. Now understand, I put a 1 on top because will 1 raised to the first power, will that change that power? 1 times 1. No. Will 1 times 3 change that power? 1 times 3 is 3, so it doesn't change that power, right? You get what I'm saying? So I have to put the root on bottom, and I put a 1 on top so that I can bring the 5 down to the bottom. Because 1 is not going to change either of these. So our final answer would be 5. 5 to the first is just 5. X cubed. And they're both raised to the 1/5 power. They are both under the same root. The 1 just helps me bring the 5 to the bottom because 1 doesn't change either of these. Does that make sense? I honestly sat and debated, how am I going to explain it because it's just kind of hard to explain. Yeah.
You get the...
Because I've got to specify that both of them are under the same root. Yeah, good question. What?
3 just doesn't go to the...
Right. So this keeps them, very good. So it keeps the 3 only to the x, right? Isn't this only raised to the, isn't the 3, if the 3 was on the outside, wouldn't it be to both? And it's not to both, right? So it keeps them assigned to their individual powers, right? Everybody, are you paying attention? Because some of you are just kind of looking at me and I don't know. I kept them assigned to their individual powers, right? But I specified that they were both under the 5th root. Is everybody okay with that? Let's do another one. So look at 20x cubed. Yeah.
Sorry. So on like your first power, do you always put the first power?
I just did that to show you that they have their own powers. So then this would be more simplified because it's this 5 to the first is just 5, right? So I was just showing you that they have their own powers. Okay, so let's look at this one. 20x cubed, and they're both under the square root, right? Root? Everybody? They're both under the square root. So 20 is not raised to the 3rd power, right? 20 is raised to the 1st power. But, so I have 20 to the 1st and x to the 3rd. Now, are they both under the square root? Yes. So there's no way for me to say, oh, they're both under the same root without putting in parentheses. But I kept them assigned to their individual powers. So it's a square root. Roots have to go on bottom. Well, you can't have something blank on top, right? Do you understand why I put 2 on bottom? It's a square root. Roots are on bottom. So you can't have blank on top, but we know 1 times anything is just itself. So we can just put a 1 in there. Because 1 times 1 is just 1. 3 times 1 is just 3. So it's still the same thing. So what we have is 20 to the 1st is just 20. So 20x cubed. And then it's raised to the 1/2 power. Now look. It specifies that 20 was not raised to the 3rd. Only x was. But they're both under the square root. Does that make sense, everybody? A little bit harder.
Yeah.
Okay. So look at these two. I'm going to show you, hopefully this will help make sense a little bit. If we were to compare the 2 different things here, we have the cube root of 16x squared, all squared, versus the cube root of 16x squared. So the very big difference is the parentheses. So this one's the easy one. Are they both raised to the 2nd power? Are they both under the same root? Are they? They sit under the same root.
Yeah.
So we can write it easily. They're both 16 on x, and they're both raised to the 2nd power, so powers go on top, and they're both under the same root, and roots go on bottom. So this is the easy one, right? Okay. So then let's look at this. So the next one, this is different than this. This doesn't have parentheses. 16 is not raised to the 2nd power. 16 is raised to the 1st power. So we're going to keep them assigned to their individual powers. 16 to the 1st, x to the 2nd. Now, obviously, they're both under the same cube root, and roots are on bottom. So I've got to write the 3 on bottom to specify it's a root, right? And the only exponent that could go on top and not change anything is a 1. So our final answer would be 16x squared raised to the 1/3 power. Look at my 2 answers. Don't they look pretty different? Yeah, and they are different. Does that help kind of solidify the difference a little bit? Okay. So do problems 19. So we're skipping to 19 through 27. Ready, set, go. Almost easier. So now we're going to go the other way. We're going to rewrite these things that are written with rational exponents in radical form. So everybody, here we go. Let's move on, guys. So we're going to rewrite this from rational exponents to radical form. So what root is it?
Square root.
It's a square root. Roots are on bottom. So it's x to the what power? 5th. There's our answer. We rewrote it from rational exponents to radical form. Is everybody okay with doing that one? Yeah, right? Isn't that? Yeah? Okay, what's my root on this one, Riley? So it's a cube root, right? Of x to the what power? Good. So it's almost easier to go backwards, huh? Yeah? Okay, let's do another couple. 15x. Guys, pay attention to the little details. Once again, 15x raised to the 3/2 power. Is there parentheses?
Yeah.
So are they both under the same root?
Yes.
So it's a what root? It's a square root, and then is 15 and x both raised to the same 3rd power?
Yes.
So I have to put it in parentheses, right?
Yes.
Okay. All right, let's do this one. Are these both under the same root? Yes, they're a cube root of both 2 and a are both raised to the what power? 1. So I'm going to push you to be more advanced, and if you see something raised to the 1st power, we know that that's simply the cube root of 2a, right? 2 to the 1st is 2, a to the 1st is 1a, right? So I'm going to push you to go one step further and just write it in the most simplified form. Is everybody okay with how to do those ones? Okay, a little bit more advanced here. Careful. Everybody, hopefully this will help click in your mind. Is 15 and x both raised to the 3/2 power? No. What's raised to the 3/2 power? Just x. So really what we have is 15 times by x to the 3/2 power, right? Is 15 even under the root in this one? Nope. So we have 15 times by the what root? Square root of x to the 3rd power, right? So our final answer written in the most simplified form would be 15 square roots of x cubed. 15 times that is just 15 times that written like this. Okay, so looking at this one, 2a to the 2/3. What's raised to the 2/3? Just a. So we have 2 times the what root? What root? Cube root of a to the what power? Very good. You're feeling okay about these? Okay, so look at the difference between these two. We're almost finished. Stay with me. So we have 4x raised to the 1/3 power. Are they both under the same root?
Yes.
Yes. So it's going to be a cube root of both 4 and x to the 1st power. So we know that's the cube root of just 4x. Now that versus 4 times x to the 1/3 power. Because there's no parentheses, this is just 4 times by the cube root of x to the 1st. So what that really is 4 cube roots of x. Look how very different those answers are. Completely different, yeah.
So squared is two-dimensional. Cubed is two-dimensional. No, it's not.
No, it doesn't work like that with cube roots and square roots. No, it doesn't, unfortunately. Okay, do problems 10 through 18.
Makes sense.